The recording started, and we're going to start the broadcast, and we'll go ahead and get going.
The broadcast is now starting. All attendees are in listen-only mode.
Hi, and welcome to today's PASS Business Intelligence Virtual Chapter webinar. We're glad that you've joined us for this last session in May, and we're going to have a great session. Ginger Grant is going to be presenting the top 10 SSIS tuning tricks, and so we're excited for that presentation. I do have a few administrative things that I need to go over before we get started, so just please bear with me real quick. Just a couple things to mention as we move forward with the presentation. One of the things that the PASS Board of Directors wants to make sure that y'all are aware of is that the profile that you have in your SQLPass.org site needs to be updated so that you can vote. So make sure that you go out to SQLPass.org/mypass and update your profile, log in there to make sure that you get an opportunity to vote in the elections. This is something that's probably pretty popular. Of course, if you register before July 12th, the registration fee is $17.95 for the PASS Summit 2015. And right now you can get a discount by using our virtual chapter discount code, and that's VC. So Victor Car 15 BRD5, and it's down here at the bottom of your screen here. That'll be available. Just to kind of mention, of course, there's plenty of other virtual chapters, and we encourage you to make sure you participate in any ones that you're available to participate in. Each of them will have different webinars that they're presenting, so it's a wonderful opportunity for you to obtain free training. Along those same lines, of course, there's meetings that are coming up. You'll notice that they're all up for the month. We're almost at the end of the month of May. So just go out to the SQLPass.org website, and you can click on each of the virtual chapters, and as we roll into June, they'll have their next presentations. Along the same lines of free training, and these are definitely beneficial opportunities for you to take advantage of, is the SQL Saturdays. I've been to the one in the Metro Atlanta area. It's a wonderful opportunity to get free training, wonderful speakers. You can see there's a couple left for May, and you can always go to the SQLSaturday.com website and see the upcoming events. I believe there's one that's coming up in Chattanooga, I think in June, and there were several others that I noticed that are available. So what can you do to help the SQLPass entity in our organization? There's plenty of volunteer opportunities. We're all volunteers. Myself as a host for these sessions, we volunteer, and there's plenty of other opportunities that are available. One of the most recent ones that's very interesting is I was on the selection committee for what's going to be presented at the PASS, and so I was able to, as part of the abstract review teams, going in and looking to see what abstracts are going to be presented during the summit. So there's plenty of opportunities for you to get involved. And then finally, speaking of getting involved, there's plenty of opportunities for you to stay involved with communication from SQLPass. Of course, there's LinkedIn, there's Facebook, there's Twitter, and of course the PASS website. So what I'm going to do now is I'm actually going to turn it over to Ginger. It's going to take us a second for us to switch over to her screen. And while I'm doing that, I just want to mention that Ginger is currently a consultant with PragmaticWorks, and she's worked with the BI stack for many years. And is covered from a consulting standpoint, done consulting with many different industries. So Ginger, I'm going to go ahead and turn it over to you for a takeover for our presentation.
Well, thank you very much, Scott. So thank you for taking time out of your day to attend this webinar, and I'm assuming everyone here is pretty familiar with SSIS and is interested in how to make it better. Well, I've been playing with SSIS for a while, but I remember when I first started using it, and I really wanted to figure out how to make my code better, and there was a guy on my team who really knew how to tune SSIS and make it fly. This meant whenever anyone on the team had a slow-running package, they gave it to Greg to fix. And how Greg fixed it was he checked it out of SSIS and he tuned it. And I asked him, what'd you do to make the code run faster? And he answered something like, oh, it's really complicated, or oh, I had to play around with it. And he never did tell me or anybody else what exactly he did, and that I thought was pretty annoying, so I started being motivated to go figure out, hey, what can I do to make my code faster? So that's what I did. So today we're going to be talking about 10 things you can do to improve your SSIS code. If you were to ask me what was the #1 thing you could do to fix your code, because I'm a code consultant, I would give you the standard consulting answer. It depends. I haven't seen your code, so I don't know which solution could improve it the most, but I'm sure that many of the things that we're going to talk about today could really help. On that note, while I'm talking about the 10 things, don't get too invested in the order. Going back to it depends, the #1 thing for you may be the number 10 on my list. It really doesn't matter, which order the things are. And lastly, for anyone out there who thinks that the reason their SSIS code is slow is because SSIS can't go any faster, I just wanted to dispel that thought right now. SSIS can be very fast. It is shown to be able to process 4.5 million transactions per second, and that's just fast. In order to make your code run that fast, though, you're probably going to be able to have to modify it a little bit. So hopefully by now you're interested enough in the topic that I can post up some of the less interesting information and you won't drop off. I wanted to make sure you could get a hold of me later, so I put up some ways to contact me here, because I don't really think that learning has to end after 1 hour today. So please feel free to contact me. I'm pretty active on Twitter. One could make the argument that I spend way too much time on it, and I put my blog up there because I have been doing a lot of contributions to it. Earlier this year, thanks to Ed, Leighton Dick, I did the SQL New Blogger Challenge, and that motivated me to write some more, and I generally try to post something up new about every week, so feel free to subscribe if you want to see what new business intelligence things I'm writing about, because I kind of go all over the map. So I do quite a bit of speaking, and I really enjoy this opportunity. And one of the things that I was able to do last year is I got to be a finalist in the 2014 Redgate Tribal Awards for New Community Voice, which I thought was really cool. I really am interested in trying to become a better speaker, so I've got 2 links. One of them is the actual link, and then the speakerrate.com is actually the site, which might be easier for you to remember. Because I am interested in what you think of this presentation, feel free to post comments regarding this talk there. My next speaking engagement that I'm pretty excited about, so I put it on the slide, is 24 Hours of Pass. And I'm going to be speaking on June 24th at 5 p.m. Eastern Daylight Savings Time. So now it's back to SSIS. So starting off with number 10, drum roll in the David Letterman style, in-memory transforms. What do I mean by that? Well, keeping things in memory is the fastest way to process an SSIS package. If your data overflows your memory buffers and ends up writing to disk, you pay for that with a noticeable decrease in your performance. Instead, the idea is to try to group the data into buffers which occupy all the memory without going over. I call this the Price is Right method. If you can figure out the size of the buffer as close as possible without going over, you're going to win the fabulous prize package. Okay, that's where the Price is Right analogy kind of falls apart. But sizing your buffers appropriately is still a big win. Of course, guessing what the buffer size should be is a lousy way to proceed, as chances are you won't be able to guess right, so don't guess. Instead, use some of the ways we are going to talk about to figure out what the buffer size really should be. And one of the ways to figure out if your buffer sizes are too small is take a look at the performance monitor, see if you're swapping your cache to disk. Another way to determine what your buffer size should be is it talks about just looking at your code to determine how much buffer space is needed. For example, if your code contains tasks like big sorts, well, those are notorious for taking up a lot of memory. Perhaps you can figure out a way to write your code so that you don't need to do that in SSIS. And we're going to talk a little bit more about that later as well. And to ensure your buffers are the appropriate size, there's just no substitute for figuring out how much space you'll need and then allocate the appropriate amount for storing the data. And memory is consumed based on the size of the row, and it tries to dynamically size the buffer based on the row size. SQL Server estimates the row size by looking at the maximum size of all the columns in a row. And this brings up another best practice point. Hopefully you've heard this before, but if you're not, you're hearing it now. Do not write SQL code anywhere, including, of course, within SSIS, that starts out or contains anywhere in it the two words select and star. Okay, for all you literalists out there, yes, I know that star is really a symbol, not a word, but you get my point. Don't do it. Have some pride. Don't be lazy and don't write select star. Why? Nobody ever tells you this. Why? I'll tell you why. Every time you do a select star, you're making the engine do 2 reads to SQL Server instead of 1. This is where select star will hurt you. Every time the SSIS engine sees this, it'll have to read the source to determine what the columns are and then get the metadata. And you can eliminate one of these steps by just listing the columns. SSIS will try to do this dynamically to determine the buffer size. It's sort of a loose algorithm, but by specifically tuning the buffer size to the size you're actually using, your performance can be a lot better. So, if you wish to monitor how your SSIS package is performing, there really isn't any better way of doing this than by looking at the performance counters in perfmon while your package is running. I generally do that going to start and typing perfmon, and then when I do, I get this screen up here. And you'll notice that I've got these buffers down here in the bottom. And this is from my computer, which is uniquely called laptop. And I'm looking at the SQL Server SSIS pipeline here, and I picked that by clicking on this plus button here, which says add. And I have to pick laptop. And then scrolling down and looking for SQL Server SSIS. And you can see there's a number of things you can monitor. If you've never looked in here, this is kind of a fun thing to play around with it. So what's interesting is that I have pipeline 11, because I have SQL Server 2012 and SQL Server 2014, which is 12, which just seems backwards, but that's okay. And I figured out which pipeline I was using by looking at my performance counter. So I've already selected these, and once you have selected them, it doesn't show that you've added them here, but it shows that I've added them here. So the reason that it's not doing a whole lot is because I'm not really running any SSIS now, but I can change that. So I've got this kind of simple package that I created out here. This reads a lot of rows, so I'm just creating a table, and then I've got a derived column, and then I'm doing a lot of row writes. Just kind of a simple bit of some SSIS code so you can see how perfmon is working. So I'm going to go ahead and start it, and then flip back here to perfmon and see what it does differently. And it's now running. I'm looking at all of our monitors here, the things that we can look at to see what it's tracking. And so you can kind of look to see all the buffers that are being consumed. One of them that you really want to keep a whole track of while you're doing this, going back to perfmon here, is looking at the buffer spooled. But monitoring your performance over time, modifying your code to see how it performs over time will really help you out in determining what you can do to tune it, because in order to tune it, you need to know exactly what it's doing while it's running. So, and I understand that this will work differently on the server than it will in your machine. Ideally, it would be nice if you could be able to do this on the dev server. I know certain environments aren't necessarily conducive to that, but if you do get the ability to run perfmon while your job is running, it'll be really helpful so you can determine exactly what your package is doing. All right, next thing that you can do is basically to determine the appropriate size of your buffers, you need to know how much of your data is actually taking up. And I put the code up here so you can determine how to figure it out instead of flipping back to SQL Server, because I just thought this would be simpler. If you're interested in some step-by-step instructions on how to determine your row size, I posted how to do this on my blog so you can see a more detailed version of this. But basically what you run is, in this instance, I'm looking at the space used for person.address, and obviously that came from AdventureWorks, and it's showing me that when I run this, that I got 19,614 rows came back, and it took up 2,784 kilobytes. So if I divide that and times it by 1024, then then I can get a number that I can determine what I can use to determine my buffer, to my buffer size. And that's how this calculation works, and that's how you can determine what size you should set your buffer to be. Number 9, the next thing you probably want to look at is baseline your source speed. In order to determine what is possible to do in your environment, first you have to know what your server configuration is capable of doing. I mean, there are limits on how fast you can make some things go, which you might find out if you've ever in the past rented a Dodge Neon. Sometimes putting the pedal to the metal will only get you up to 70 miles an hour. And server and network combinations can work the same way. One of the reasons it is important to know how fast it's possible to go is if you are having an ongoing discussion with whoever is managing your server resources. You might say that the server is over-allocated or just flat out doesn't have enough memory or fast disks. And the person managing these resources may come back and say, you're just making excuses because you're writing really slow code. Don't argue. Just present the facts, which is how fast is it possible to read data in the first place. The place to do this sort of analysis is, of course, not in the middle of your complex, mission-critical, one package to rule them all SSIS project. Create something really simple and run that. Ideally, you should watch the performance in perfmon to see exactly where the bottlenecks are as well, because you need to know how fast integration services can go. If you can't be tuned past the speed of your source. So you can't transform data faster than you can read it. So it does come down to that. So another thing that you can do to determine the read speed is measure the speed of your source system by creating a very simple package, reading from your source to destination with row count, which is pretty much what I did here. This is really all you need to do to have a package to benchmark your system. And of course, if you're running this in production, you will need to put this in production to determine how fast it's possible. You want to execute the package from the command line and measure the time it took for it to complete the task. You can also use the log output to get a really accurate calculation of the time that it took to read the data. And you want to calculate the rows per second. So take the number of rows by the read time of the data flow. And this will tell you how fast it's possible to read the data. So you know how fast it's possible in your environment for things to go. To enable logging on the data flow task, make sure that you select the buffer size tuning event, and that way you can see how many rows are contained in each buffer. And also, to really be able to measure performance, you need to make sure that you're using the appropriate drivers. When integration services and SQL Server run on the server, make sure you use the SQL Server destination instead of the OLABD destination. That'll improve the performance as well. So, make sure that you're using the latest drivers for whatever source that you have. Number 8, understanding resources by exploring performance monitor. Yeah, back to that again, which is why I wanted to show it to you. CPU, what you want to look at is the process and processor time for both SQL Server.exe and dtexec.exe. SSIS should be close to 100% of CPU. If it isn't, check your hardware and make sure that your package is taking advantage of parallel threads and SQL Server is not taking all of the memory for itself. With memory, it's best to figure out how much your package uses. Look at SQL Server, Memory Manager, and total server memory on perfmon. And threads, the default for that is 10. And the books online says you need a thread for each object, but I found out this is not always the case. And one thing about allocating threads, the threads are taken whether you use them or not. So if you over allocate your threads, you're just reserving things that can't be used. So a kind of a guideline is a thread for each object, but you want to play around with that, evaluate it in perfmon to see if that's really right. I/O, hey, that still matters. So you need to understand SQL Server and the I/O requirements of your package. How much reads versus write are you using? What are the typical rates? Talking about benchmarking. What are they rating from your sources? Because your source may not be reading from SQL Server. Your source may be reading from a flat file or another database system, in which case you might want to benchmark that to figure out how fast it's possible to read from that system. So you want to look at, average read bytes per second, average writes byte per second in perfmon, disk read bytes and per second, average disk sec write, and average disk queue length, and the one thing to remember is I/O is sequential. How much of your I/O is random? Is this, OLTP, or is this data warehousing? All this can help you determine how to best to configure it. Ideally, if you can, you should put your log files on your RAID 1 or RAID 0 disks. This provides better perfection from like a write performance perspective. Make sure that you do not have your log and your data on the same physical disk if you can help it. Sometimes I know when you're writing SSIS, you don't have the ability to tune some of this hardware stuff because perhaps your DBA does, but hey, I'm thinking OpDev so that you have the ability to do all this kind of tuning. One of the things is, you just can't overlook some of the SQL Server basics when you're writing SSIS. You still need to know how SQL Server works and what you can do to improve it. If you're reading for a number of different data files, SQL Server uses a proportional fill-out algorithm, and so it allocates files with more free space. So, watch your data size and log files. Within SQL Server, do not rely on auto-grow. This gets to be a really big deal with SSIS because a lot of times we're writing a whole bunch of data to SQL Server, and a lot of the times the DBAs will put on auto-grow so that we don't blow up the disk by taking everything up. Well, if you have to use auto-grow to increase the size of SQL Server's data allocation, your package is going to be slow. Ideally, you should know how much space your package is going to take up so that you will allocate that space in advance and not have auto-grow turn on, which should really only be there as a safety measure, so that way that your package isn't slowed down by the physical hardware of SQL Server. Number 7, optimize your SQL. Yeah, it still matters. One of the things that I don't know it's necessarily possible to do this because it depends greatly, there we go again, on your tables, if you are able to drop the indexes. Of course, cut back to SQL 101, if you have to write indexes and you're writing a rows, that's 2 writes. 2 writes is greater than 1 write, and if you can drop your indexes, add all your data, and put your indexes back on, it will be faster. I realize that some people may be saying, well, you live in an ideal world, and I get that. It's not always possible. But take a look at the SQL that you're using inside your SSIS. Ideally, you should be using stored procedures for that. Don't put a whole bunch of SQL code in your packages if you can get away from it, because compiled code will tend to run faster. On that note, look at your execution plans. This is, of course, is a subject onto itself, which I don't have time to go into at length. Grant Fritchie, of course, is the master of this, so I recommend looking at his site. And Redgate has a free book on how to read execution plans. Just because you're doing SSIS doesn't mean that you can get away from the basics, being, how is my SQL code that I am running in this SSIS package doing? Determine the best method you can for reading data into SSIS. Make sure, are you using cache? Are you using tables? What kinds of things can you do to improve the way that you're reading data in? Number 6, partition the problem.
Hey,
well,
Ginger,
yes?
Hey, Ginger, can I interrupt you? Along those same lines, is that people were talking about reading data, and you made a mention to using the right drivers. And one of the questions that came up is, could you kind of go back over that real quick about, when you're reading the data,
Sure.
what's the correct drivers?
Well, yeah, because it's, I have to remember where I can. One of the things to remember about drivers that I did mention just really briefly is when SSIS catalog and SQL Server run on the same server, using the SQL Server destination instead of the OLABD destination will improve performance. If they're not, physically on the same server, you do not have that kind of performance gain. But that's the kind of thing that you will want to take a look at, to how you are architecting, where you're reading and where your SSIS package is running. Hopefully that answers the question. And in addition to the obvious things like making sure that you are using the latest and greatest drivers for whatever source that you happen to be reading from. So hopefully that answers the person's question.
Sure.
Asked. But good question, and thanks for stopping me in the middle and asking me. I really appreciate that. Back to partitioning. If you're reading the data in, if you can create partitions so that you don't read all the data in huge chunks, so that you get the data in smaller increments, that can be really, really helpful, because the total runtime is set by the largest sized item. So believe it or not, it's faster to go to the same source 5 times than to go to one source that's absolutely massive. And if you're going to be doing that, try to read your data in equal sized chunks. So if, again, looking at the total runtime. So if you're reading data in, try to see if you can, and you're reading, don't do the one huge, it takes forever to read in package if you can prevent it. One of the things also, this goes back to your basic SQL stuff. Consider table partitioning using alter table switch, and this is a really neat topic onto itself. Catherine Williamson has a great post that she put on Pragmatic Works blog on the intricacies of this and how it works. And if you get a chance, I highly recommend going there and reading it, because she's really gone to a great amount of depth to explain how alter table switch works, and that's something that also that you could start loading data in SSIS to take advantage of this. So go ahead and check that out for more in-depth details on the alter table and switch. And a shout out to Catherine for her great blog on it. One of the things you can do, like I said, is create file groups for the partition tables, create the partition function, just kind of like I'm doing a high-level overview of what's involved, and then create the partition scheme, which uses that partition function. And then you would need to modify the table and corresponding index to use those structures. And here's basically, what you need to do from an SSIS perspective. Load the data into a new staging table. So don't load it into where you want it to go. If you've got your partition set up, then you just use alter table switch to put the data in. And this can be a much faster way of doing writes in SSIS. So it's kind of a neat trick. Number 5, tune the network. Okay, this gets into something that you may or may not be able to do. To overcome some of the limitations of drivers, you can start doing multiple connections to your data source. And if your data source can handle many concurrent connections, you can see an increase in throughput if you have many extracts at once. But if concurrency is kind of getting to be an issue, you might want to see if you can get your packages read from different partitions to more evenly distribute the load. This gets into multiple NIC cards. If the network is the bottleneck, and you've determined this by looking into, perfmon, and and obviously this is never going to happen if you're doing everything on one box, but again, this is environment specific. And if you've already ensured that you're using gigabit network cards and routers, and if you can, the multiple NIC cards that you can use when you're connecting to multiple sources can be very helpful. And this gets into network utilization. So by default, this packet size here, it's set up to 4K, and 4K is the size of the packet sent across your network. The biggest value that you can set it to is 32K, and I did this obviously within the native OLDB client, but me setting it here is a complete waste of time, because it's not going to be able to use these large package unless on your network administrator side that the jumbo frames has been enabled on their switches. And a lot of times there's some reticence to doing this because when they set the jumbo to enable jumbo frames, it's not just going to be used for SSIS, it's for all the network traffic. So that being the case, you know, depending on what you're doing, you may see some reticence in doing that. But this, you know, this being set to 4K, don't just go off and set the packet size to 32.767 because if your network switch isn't set to jumbo frames, this won't do a thing for you. So, and the default size is 4K, and that's generally the same as the switch size. So you're going to have to coordinate all that to make that be able to do anything with it. Number 4, use the right data types. Yeah, this basic stuff is still very important. One of the things that you might want to watch for is precision. Obviously, float is a big is not going to be as fast as, say, money, but money has fewer precision considerations than float does, so you might not be able to use it. But a lot of times people forget that they can even use that because it's just a short little, just does 4 places beyond the decimal point. But sometimes, hey, that's all you need. That can be, you know, a really efficient data type. Char versus varchar, this I've heard a lot. Also, nvarchar. If you do not need to take 2 characters for each letter that you are saving off, there is no reason to use nvarchar. I actually worked on at a client, and they had everything as nvarchar, and it was but domestically based in the US. All they're doing is wasting space. There's no reason to have nvarchar unless you're doing a lot with special characters and you need 2 characters. If you're using a fixed length field, use char. If it's 5 characters or less, use char. Varchar is better, obviously, if you've got variable length columns and anything longer than 5 characters in size. But for columns that are, you know, going to be fixed, use char, not varchar. Also, try not to cast too much, especially within SSIS, because if you are casting your code into, you know, various different data types, it slows it down. Ideally, if you do need to cast, do it in your source. Obviously, you can do that within what's selecting the source, but that would be a better, if you're going to cast before it gets into SSIS rather than after, because it's not as efficient to do it within SSIS as it is outside. So just kind of keep that in mind. Schedule and distribution. The goal is to avoid one long running task dominating the total time of the ETL flow. So break it up. One of the ways that you can do it, and this is one thing that people aren't that familiar with, is by downloading a free tool for Microsoft, which is included in the SQL Server 2014 feature pack. How many people actually knew there was a 2014 feature pack? If you don't have 2014, yes, there are other feature packs available. As a tool to increase parallelism on the code has been available since 2008 R2, which is what a lot of you may be running. Hopefully you won't be surprised when we look at this slide talking about the tool, the Balanced Data Distributor. You probably guessed that one, right? No? All right, so this is part of the pack that Microsoft provides, and what it provides is this little tool called Balanced Data Distributor. And all it really does is efficiently balances your code. So, like I said, the ideal here is to avoid the one long, huge running package. So on your left, I've actually just clipped my code out because I just thought it would be easier to describe it this way. And what I've got is I've got you know, OLTP source. I'm doing an aggregation. I'm doing a sort. I know, not very efficient, but I'm trying to get it to do some running here. And then I'm doing a derived column, and then do an OLTP destination. So what you do with Balanced Distributor is you use it, and then you copy your code so that you're running it 2 or 3 or 4 times. Balanced Data Distributor automatically for you balances the loads out. So this is actually going to the same destination. It's back to AdventureWorks. But if if you are writing to it, and you can write to it it's much easier to write to it 4 times faster. And all you need to do is insert the balanced data distributor component in there, and then copy your code over as many times as you wish. You may find that twice isn't good for you. You can do this 3 or 4 times. So this will use multiple threads, and how many times is determined by you. I split this in half. So, and I did aggregate and sort so I could show you some blocking transforms. I wanted this to be bad code. This is not what I recommend you writing, but I wanted to show the difference. And I do have step-for-step instructions on exactly how to do this on my blog at Desert Isle SQL. So go there and look at Balanced Data Distributor, and then you can have step-by-step instructions on how to actually make this fly. And it's kind of a really neat tool, and not that many people are using it, and it's something that I think that more people really within their SSIS packages need to take advantage of.
Hey, Ginger, is that available for any prior versions to 2014, like 2012 or 2008?
Yes, it was released in a new SSIS transform for 2008.
Okay.
So it is available. It's a little harder to find, but it is in the Microsoft pack for 2008 and forward. So every single version since then, it's available to you. So it's really funny because it's been available since 2008, and I use it, and I've not seen anybody else. I've not seen any other code where people are using it,
Sure.
and I really think people should take advantage of it.
Definitely.
So,
Definitely.
yeah,
Right.
and it's free. So, and it's, Microsoft provided it. I don't know why they don't just include it within SSIS, because I think it should be one of the tools that everybody should have so that they can use it.
Exactly. Exactly.
Yeah. So, next, number 2 tip is minimizing log operations. Now, this gets to be a really big deal with 2012 and beyond, because you can log the planet. And while that is a really neat thing to do when you're developing, remember to turn it off. Do not always have all of your logging on all the time. If you're using the project deployment model, which I really hope you are, because project deployment in 2012 offers a lot more flexibility in configuration settings. But one of these things you can do is do this on the server. So handle because it's easier to handle your logging on the server and do the maximum logging there. That way it's easier to notice that you've got all your logging turned on, and you can turn it off. If you bury it in the package and put it in the event handler and click on all these little components and log everything because you had a problem and you were debugging it, and then you forget to take it off, it's not that easy to determine that you did this. I know that a lot of times people don't even realize there is event handler logging. I worked at a place where somebody had embedded sending all the error logs to his personal email whenever any of the SSIS packages broke, and we were wondering how come we didn't know when they were broken. It's because he buried it in event handler logging. So know that you can do this, but you really want to kind of have some policies around this or make it minimal, because with 2012, I really think that you're probably better served to do server level logging and then turn it off, just so you don't forget that you've turned it all in. All right, well, looking at the number 1 thing, lastly, that you can do to improve your SSIS package is to write good code. I left this as number 1, as it tends to be the number 1 thing I end up doing when I'm fixing SSIS packages that are too slow. So what kind of things should you look at or not do in your SSIS package? Well, avoid using processes that slow down the flow, like semi-blocking or blocking transforms. Data flows in SSIS use memory buffers, and those are allocated for using and storing of your data. And if there are ways to reduce the number of memory buffers required, you can make your code go faster. Now, I know that there are times when it's not possible to do this, but if you can, do it. The other thing thinking about that is do not use sorting in SSIS. If you can, don't do it. This is much more efficient task to be done within your source system. So if you can get away with it, don't sort in SSIS. In case you can do, sorting outside most of the time. So, you know, back in the day, I remember seeing, and if I'm being honest, writing packages where I'm extracting some data from two different sources and then adding a sort component and then merging. Don't do this. Sort your data in SQL when at all possible, and then you don't need to add that sort component before you do a merge. So just one of those little best practice tips. If you see somebody who's got a sort before their merge, they probably didn't know this. I know I didn't for a number of years. So sometimes you can tell a lot about the author of a package, or a stored procedure for that matter, based on how it's been written. And if you're looking at an SSIS package from somebody who's got like a big-time developer background, you're likely to see a lot of scripts in the code, and there's nothing wrong with that, as long as they're not doing row-by-row level processing of all the data in your SSIS package. If you see somebody who's from a developer background who's done a stored proc, they might have one that uses a lot of cursors. Both of these things are to be avoided. SQL Server and SSIS are set-based, and that means that they do not process row-by-row transactions very efficiently. That's not what they do well. They do sets very, very efficiently. So try to group things and process them rather than look at this row and look at that row, and that would be a better way of doing it. So how can you do that? Well, if we're looking at changing the design, one of the things you might want to think about is that there's two different kinds of data transforms, synchronous and asynchronous. Well, what are they? Well, a synchronous transform is something like a derived column, and that means that you get as many rows in as you get out. And that way they can use the same buffer. They don't need two buffers because they can reuse the existing one because it's the exact same size of the first buffer. So, but if you've got an asynchronous transform, that, like you're doing an aggregation or something, you would insert 100 rows in, and you get, say, I don't know, 20 rows out. Because of that, you can't use the same memory buffer. You have to use a new one. So if you use a lot, if you do those kind of transforms, you end up using more and more memory buffers. So in case you couldn't remember, you know, which kinds, and of course the worst of the asynchronous ones are blocking, and the less worst ones are semi-blocking. But I know you have to use these sometimes. I'm not saying don't use them. I'm saying if you can eliminate them, or you're wondering why your code is slow, this is why. The semi-blocking transforms are things like data mining, merge and merge join, pivoting, term lookup, and union all. So if you can, if you're wondering, your code will bottleneck until, because you know, do a semi-bottleneck when those things are applied. But if you use blocking transform, basically what this means is that until that step is done, your code's at a flow halt. So aggregates, fuzzy grouping, and lookups, row sampling, and sorts, they're blocked until that task is completed. So if you can eliminate or decrease the number of ones that you can use for this, that would be a really good way to improve your code. I'm going to hit on this really hard because it's one of the things that I see all the time. No sorting. Sorting makes things fall out of memory, and SQL Server is better at it. So, and I have seen this over and over and over again, and every single time I was able to take it out because I had was either writing SQL to a SQL Server, or I was writing PL SQL, and I could do my sorts in my source. Just because of Microsoft put the sort component out there doesn't mean you have to use it. SQL Server is better at sorting. Okay, so back to change the design, talking about being row-based. One of the things you want to make sure is that your code is taking advantage of set theory whenever you can. This can mean that scripts can be problematic. Now, not every script is, but if you have a script where you're reading a set of records, and you are say adding them up one row to the other row to the other row to the other row in a script, that's row by row, and that can be really slow. So any kind of processing where you're looking at one row, then another row, that is going to be a slow task. And sometimes I get it, you have to do that. But if you can get around it, don't. The other thing that I will say, because it is a row by row, really slow task, is don't use the slowly changing dimension task in SSIS if you can get away with it. it is really, really pokey. There are other ways to accomplish the same thing, either by writing code or, hey, Pragmatic Works makes a really good tool to do slowly changing dimensions that's not really, really slow, so that would be another option that you can do, or you can write the code yourself to do it. But generally speaking, using the slowly changing dimension task in SSIS is really pokey, and you probably shouldn't do. All right, so to review, here are the top 10 things that you can do to improve your SSIS code. I don't know that I mentioned this earlier, but the main reason that I picked these 10 things and not some others that you may know about and use is I didn't really come up with this list. Microsoft did. And because they listed this as the top 10 things that you can do to improve your code, I figured that these were the most important things to focus on to make sure that your code is running as well as it can. And a lot of this is on you because it's about learning how your code works and learning what your code does. And I understand that not all of this is possible. Hey, you're not may never get your network administrator to agree to use jumbo frames. You may not have the ability to run perfmon on the actual server that the code is running, so that you don't know how things are actually running. But anything you can do, you should. And a lot of that is, is understanding design, understanding what the components do, and understanding what your code needs to do to be more efficient. And hey, if you can break it up, that would be a really good thing to do as well. All right, so I've left about 10 minutes here for questions. Does anybody have any additional questions? I see there on the chat that somebody has posted Catherine Williamson's blog on using the partitioning and switch. So thanks, Catherine, for doing that. Are there any other questions that are out there?
That was definitely one of the questions that popped up, was folks were asking about how to get to that. And as Ginger mentioned, you can go over to the chat window in the GoToWebinar panel, and you'll see the link in order to get to the noted information. And if anyone else has questions, please feel free to post them in the Q&A area that shows up on the control panel also. And there were a few questions that came up, and I was able to answer them as they came up. But let's see if we can get some other folks that will post some things. Okay. You mentioned, first question that came up, you mentioned dropping indexes before inserts. Is this all the time that you'd want to do this? I'm assuming that's what he means.
Ideally. If you can get away with it now, because it's always going to be slower. Now you can also argue that if I have to put all the indexes back, that's not necessarily an efficient way to process either. But that gets into the it depends things too. And if you are doing a huge insert, you probably want to rebuild all your indexes afterwards anyway. So it's a good performance step from that perspective as well. Thinking about that, as I saw an interesting post recently on the use of foreign keys. Leaving foreign key constraints on turns out to be a very negligible performance hit. So I do not recommend, and I can, I'll post the link to that on my blog if people want to do more on it. I do not recommend taking off your foreign key constraints because it's, from a performance perspective, it's not shown to be taking a really big hit.
Okay. We'll wait for another minute here for any other questions that will come up. Just to kind of mention, of course, all the virtual chapter sessions are recorded, and we will get the recording posted on the Business Intelligence virtual chapter, if I can spit this all out, Business Intelligence virtual chapter YouTube channel, probably sometime today. It may be over the weekend when it finally gets published and posted and everything, but yes, it will be posted on the YouTube channel shortly. Trying to see if there's any other questions. I don't see any other questions that have popped up. So we want to thank Ginger again for taking the time to speak with us and to the the Business Intelligence Virtual Chapter. We appreciate your time, and we hope that everyone has a good rest of the week and such wherever you're located.
Well, thank you very much, Scott. I really enjoyed the opportunity to be able to present.
Yeah. And we actually had one question that just popped up while I was doing the summary. So if you want to, I'll post that to you real quick here. It says, when dealing with late arriving data and the partition is based on date, how would you do that switching effectively? That's kind of a mouthful.
Yeah, if it's late arriving data, what you can do is put it into that partition and wait until that's kind of an interesting question, because you may not be able to use partition switching, because that's pretty much when you fill up that partition, you switch it over. So if it's very late arriving, that may not be something that works for you. If your partitions are quite large, like for example, a lot of people do it by year. So if you did like a year partition, the chances are you wouldn't have much late arriving data. But if you do have a lot, you would probably want to sort your partitions so that you didn't have much, if any, late arriving data by making them quite large, because it can be inefficient if you have a whole bunch of partitions and they're all really, really small and you're writing to all of them. So appropriately size your partitions to accommodate the data that you are using.
And I think that's it. So again, thanks everyone, and we'll look forward to seeing you on the next past Business Intelligence Virtual Chapter meeting. Thanks a lot.
Great, thank you very much.